Graphing rational functions are a bit of a puzzle, and likewise for finding the equation. But what we're going to do is we're going to set up this puzzle and we're going to say, okay, I have some function and I know it equals a fraction of some kind. And we're going to walk through this and find each of the factors according to what it's causing to happen in the graph. So take a look right here. First of all, I have an x-intercept at -3. So that must come from a factor of x plus 3. And because it's crossing the x-intercept, it's odd. So that is an exponent of 1. Okay, there's no more x-intercepts, so I'm kind of done with that. But there are two vertical asymptotes here. So here's a vertical asymptote, and here's a vertical asymptote. And notice that these things are both odd. These are odd vertical asymptotes. And most of the time, especially in the introductory problems, you're going to have odd vertical asymptotes. The even ones throw in a little extra trick. You won't see those until later. But the reason I call these odd is because look what's happening here. It's going up on this side and down on that side. Okay? That opposite behavior is what makes it odd. Likewise over here, up on this side, down on that side. That's odd. Now, when I have those odd vertical asymptotes, they're going to cause factors each with an exponent of 1. So the first on the left is x plus 4 with an exponent of 1. And then the one towards the middle of the picture is x plus 1 with an exponent of 1. Now there's a hole. We haven't talked about that yet. So this guy right here, that hole located at, let's see, x is -2. So that'll be a factor of x plus 2 on top and bottom. Okay, and in practice, you're not going to see holes with exponents on them. It's not that they couldn't have exponents, it's just that that makes the problem a little more challenging than it's worthwhile. So there's one piece left. I haven't talked about the y-intercept yet. We're going to use that. And I haven't talked about the number that is sitting out front here. It's not going to be x. If it were x, that would cause another x-intercept. It's going to be just some number, and we don't know what that is, 2, 5, a quarter. So what we're going to do to figure that out is we're going to plug in this coordinate point here. And really, you could pick any coordinate on the graph. There's one requirement. It has to be non-zero. It has to have a non-zero y value. So what I'm going to do is plug in that -3 for my y value right here. -3 equals, and I don't know what a is, but I'm going to change all my x's to match the 0 right there, because that was y. Let's be real clear about this. This is 0, comma, -3. So that's what I'm plugging in. So on top, I now have a times 0 plus 3, 0 plus 2, divided by 0 plus 4, 0 plus 1, and 0 plus 2. Okay, great. So two of these things just cancel out, right? Makes our life easier right there. So this becomes -3 equals 3a divided by 4. Okay, and that means -12 equals 3a. And that means -4 equals a. So what you do at this point is you now plug that back into your equation, and you'll be done. F of x equals a fraction. -4 is the value, that multiplier value that I found. And I have x plus 3, x plus 2, and now you have the vertical asymptotes on the bottom, x plus 4 and x plus 1, and the last factor of x plus 2 that completes the whole in the function. So there you go. No need to multiply those factors together. It's fine to just leave it this way.